Welcome to today's Connectivity Working Group call. Thanks so much for joining. We'll go ahead and get started with the antitrust statement. Chris, I see you're on camera. Could I bother you to do this?
Sure. The Advanced Water Heating Initiative, AWHI, is a member-supported collaborative of professionals from across the U.S. This diverse membership includes numerous competitors, and care must be taken to scrupulously abide by federal and state antitrust laws. Members should remember that antitrust compliance is important at all times. At this and other AWHI meetings, participants should not discuss competitive pricing, profitability, allocating markets or customers, or promotion of a particular product or accessory.
Thank you so much, Chris. Really appreciate it.
You're welcome.
Sweet. So agenda for today, we have our welcome and intros, a couple cool updates coming up. Then we will have Tristan talk about the SkyBox technology from SkyCentrics. So super fun to have one of the working group leads discussing, their own work. So that'll be very neat. Great product that's used a lot. So then we have a monthly discussion question. If we have time at the end, just, trying to get more folks involved, like I was talking about previously. There are a lot of experts on this call. So, getting everybody's input is always fun. Is there anybody who is at this meeting who has not attended before? All right, doesn't seem like it this time. So we do have a couple announcements. Especially exciting is that Energy Star shipment data was released from last year, and we saw a huge boost in heat pump water heater sales, so 35% year-over-year growth. My colleague Joe Witrunas is coming out with an article kind of digging into some of the details, so that should be released soon, either on AWHI's blog or on Clean Technica. So I'll be happy to share that link during the next meeting. But very good news, the more heat pump water heaters there are out there, the more load shifting we can do. So yeah, definitely positive trend. Hopefully we start seeing that exponential growth. And then some initiative updates. There are more upcoming webinars, including an equitable workforce one. We know that workforce development is really critical for this industry, trying to get more installers going. It'll lower the prices of installations and just really help boost adoption as well. And then, of course, Heat Pump Water Heater Day on October 23rd. So definitely don't forget to sign up for that. And there'll be events all day, so you can kind of pop in and out as you so choose. We also recently had the all stakeholders meeting. So if anybody missed that, we did a spotlight on distributors. We also talked about the various air quality districts phasing out fossil fuels, and we gave some working group updates, including on this one. And there's a recording link right here. I can pop that in the chat later, and it'll also be in the slides when this is all sent out. So with that, I'm going to turn it over to Tristan. Thank you, Tristan, for participating and presenting today. Very much looking forward to the SkyBox presentation.
Yeah, my pleasure. So first of all, I want everybody to know that generally this is the first time I'm presenting sort of anything from SkyCentrics per se here. So I really appreciate the time. I also know that I'm following Albert Brooks of Small Planet Supply, who did an amazing job last time. So I'm a little intimidated, but let's see. Let me share my screen and let's give it a go. So I believe that I need a couple more clicks. I'm going to click on this, try and make it as big screen as I can. And then do you guys see the big screen? Are we ready? Or do you see the other weird one?
Looks good to me.
All right, great. So a quick review of filling the lake and trying to solve the duck curve problems with the real-time demand response adjustments, or flexible loads, as they're being called now. So first of all, as you know, we've mostly been focused on residential water heaters, but commercial buildings have big electric loads, big water heating loads, and 98% of all buildings are not connected to the cloud of commercial buildings. It's amazing because we think of Internet of Things and residential, and this is mind-blowing. And 85% of buildings have no control systems. All of those boilers, chillers, rooftop units are somewhere in the building. They have a little DOS screen that you go in and choose menu options, set and forget. And then if you want to know all of the alerts from the sensors from the modern piece of equipment, you have to go by with a clipboard and kind of look at the menus and see what's going on. And meanwhile, buildings are 40% of the world's carbon emissions. And I used to think it was half in construction and half in operations, but it's actually 27% in operations and 13% in construction. So if we can get after those operations emissions and electrify and decarbonize commercial buildings, that's exciting. Now, as you know, Lawrence Berkeley National Lab 2 years ago came out with Grid Interactive Efficient Buildings, GEB. It's a $200 billion opportunity to have grid interactive buildings. 98% of buildings aren't connected. So there's a lot of work to be done to connect things. And that's why SkyCentrics, even though it started off with CTA 2045 modules, we've made what we've called the SkyBox, and we're going to do that. So why is it important to try and have connected dynamic daily signals? This is August 2019. It's on our website if you want to see it and use it. This is all the weekdays of August 2019 of Cal ISO. And the purple line is the one that includes the renewable energy. So that's actually the demand on the grid. And think about time of use, right? Time of use is trying to solve that peak and ideally fill the lake with shifted load. But look at how the lake changes in size, changes in start time, and that's every day in 1 month, every weekday. So I think it's really important for us to start heading, as Cal Flex Hub has studied and other people are talking about, flexible daily flexibility. And that means you want to have connected loads that can get the Midas signal from California or other. So now I'm going to go back and show you this screen, the morning peak, the classic morning peak. Most utilities have this morning peak, 6 to 8 a.m., and then obviously the big evening peak. And look at how water heaters are so wonderful. They have the same peaks. And historically, water heaters have not been shiftable or even schedulable. On the green, you see electric resistance. You see this nice, beautiful 700 watt hours for 2 hours in the morning, closer to 500 or 600 watt hours for longer in the evening. And then the orange is heat pumps, right? Lower, but still a good 300 watt hours for 2 hours in the morning. And then it's a little more spread out in the evening. So obviously, we want to take those peaks. This is a longer animation. I'm not going to stick around, but you take those peaks, slice them off, and fill the lake. And finally, this is Cal Flex Hub, an example of price shapes. And these price shapes, hourly price shapes, would ideally be delivered the day ahead every day. And we want machines that get these signals every day and can respond, maintaining customer comfort, maintaining what they're supposed to do, but shifting when they do it, water heating being a lot easier than thermostats. All right. I apologize. I'm going in the wrong direction. Whoops. So this is just a reminder one more time. 98% of commercial buildings are not connected to the cloud. Their equipment is not connected to the cloud. So we want to free the machines. So here's SkyBox. You can see that it's got an EcoPort plug socket, we call it. It's got the screws. We made it big like this because we thought we had to provide the official platform for the module. And what does it do? And who is it for? So this is the side views. And what does it do? It talks Modbus TCP or Modbus RTU to legacy commercial building equipment. So for the last 50 years, certainly for the last 20 years, most building equipment, boilers, chillers, big rooftop units, HVAC systems are made to talk to building management systems from Johnson Controls, Siemens, Schneider, etc. And how do they do that? It's 50-year-old technology. It's not internet per se. It's trying to be TCP/IP. And it's Modbus or BACnet, usually Modbus for the machines, BACnet for supervisory building management systems. And again, after 50 years, only 15% of buildings have this controlling supervisory system. Otherwise, these machines have the ability to talk Modbus, but nobody's doing it. It's literally standalone, got to go by with a clipboard. So we made this device to literally sit next to the machine, plug into it. You see the RJ45 cable. They either have that or we have a $20 adapter that can give them the green screw down terminals that you might be familiar with. And then that plug looks like a 110 volt plug, but you can actually get a 240 volt cable and plug it into the box, and it is UL approved for 110 to 240. And what does it get you? It gets you EcoPort certification and OpenADR certification, and I'll talk about that. So in the EcoPort certification, by the way, what's interesting is, we've talked about connectable versus connected out of the box. So when you put the EcoPort next to a machine, it's connectable, open standard, connectable. And you get the machine manufacturers we work with, like last time we had Small Planet Systems with their water drop systems, Small Planet Supply, and they are now on the EcoPort qualified product list as a fully independent listing because they worked with us and they used the SkyBox certification to say, hey, we are EcoPort ready. Everything's ready. And then OpenADR, they only get a qualified product list there under the SkyCentrics listing. All right. So where does it go? So I've had the good fortune now to go into commercial buildings and see these control boxes. All of the big equipment has a control box like this. And you can see there's a lot of wires here. And the SkyBox goes right here. There's two of them right there because we were working on it. And then look at how this manufacturer did something really cool over here. They put the EcoPort plate on the outside because obviously if you close a metal box, you would be sealing up the module. And if it's a cellular module and it doesn't have a flexible external antenna to stick out a hole that's usually in the bottom of these boxes, you can kind of see those holes, waterproof holes. So now we have that module and we have the possibility for an external antenna extender. So that's good. And when you actually get this whole piece, then you're connected out of the box instead of just connectable. And the good news is for all of our other CTA 2045 EcoPort module makers, any module can go into this and have access to these commercial building machines. Very exciting. So once you're connected, you can also put internal daughter card options actually into the box. So yes, you can buy any EcoPort module from SkyCentrics or anyone else, but you can also get a daughter card option inside the box just to start you off with your connectivity. And those can be cellular, Wi-Fi cellular fallback, cellular with satellite fallback, or LoRa. All right. And where does it go? So here is a big heat pump. And that heat pump was on top of a 30-story building in New York, down near that new tower. So that was pretty exciting. And then when you went inside the building, you saw that big control box I showed you. Now, who is it for? Well, we have a whole bunch of functionalities for this box. Number one, isn't it great that a utility, in the past, we had to maybe wait until they installed a water heater somewhere for them to test EcoPort. Well, now they can put this box on a tabletop, on a conference room, and they can literally plug any module in, and it acts as a water heater emulator. So they can send signals, they can see what the water heater's doing, And we think that's really useful for utilities to get more familiar with CTA 2045 EcoPorts. Also, that box for multifamily water heaters, when there's an individual water heater in every multifamily, it's a little bit for more new construction. That box can be a gateway for 25 wired Ethernet modules, which we're now making. And so those Ethernet modules, even though we're cellular and Wi-Fi, we love wired bomb-proof connections. And as you know, in multifamily, which is a really exciting space for all of this water heater control, multifamily, every apartment has their own Wi-Fi. So you kind of want to stay away from Wi-Fi if you can. Hence, a wired module is a really nice to have. And then amazingly enough, we can connect. There's a lot of off-the-shelf little controllers that have an Ethernet connection that are very inexpensive with relays and sensor ports. So we didn't put it on the box because it's so easy to add a little external box for whatever we need. And for SoCalGas, we have a pool control system for any public pool. I don't know if everybody knows this, but public pools are on 24 hours a day. They're heating 24 hours a day. And in California, for sure, I don't know about other states, you're not even allowed to put a cover on the pool. A cover would keep the heat in the pool at night really well. But in a public pool, you're not allowed in California because somebody might fall under the cover and drown. So no covers allowed. They're on 24 hours a day. So we do optimum start for gas pool water heaters. We turn it off at night. We watch the weather. We watch the wind. And we turn it on at exactly the right time so that at 8 o'clock, 9 o'clock, whenever it opens the next morning, it's on. So usually public pools are 8 a.m. or 10 a.m. start time to 10 p.m. That means we're getting 12 hours of off time, letting it cool. And because of all the data we're getting, we're able to turn that gas water heater back on at the right time. And also, we're ready for gas demand response, which is starting to come down the pike. So we have one more version of this right now, and that is a 24-volt powered cellular SkyBox. It doesn't have the EcoPort. This is just for us to be able to connect to Modbus machines in buildings, and when we don't need the EcoPort, it's a little less expensive. And finally, we have a notion of a super SkyBox. It's got a little bit more power on the CPU. It can do more connections. It has a VPN. Some of our OEM partners really like being able to get into their own machines and work on that. They've historically done that through a VPN, a virtual private network. Sometimes it's starting to replace programmable logic controllers. These are $800 to $2,000 devices that are often inside big commercial building equipment boxes. And we have this nice box that can replace it. And that's very exciting. We're working on that. And it can act as an IBB gateway. So IBB is a set of companies that have come together. It's called the Interoperable Building Box. And it means that we're using Docker containers and Kubernetes and what's called cloud native, where it's got a hybrid architecture with gateways in the building and cloud, and it's letting commercial buildings, it's basically a concept of Linux for buildings. How to help buildings have a more open and interoperable plug-and-play systems to help commercial buildings more quickly get up on the internet and become grid interactive efficient buildings. And that's going to be DIN rail mounted, by the way. So see those DIN rails in all those controls. So it's going to be smaller, DIN rail mounted, and we're very excited about that. All right, so here's some grid certification examples. This is our certification right here for EcoPort, okay? Then last week you saw Albert present water drop systems, and all they have to do is work with us, make sure that they can get the signals and respond to basically a shed and a load up, use more energy, use less energy. We try and get the power usage whenever possible. These are all part of CTA 2045-B when possible, but that hasn't been mandated yet for commercial buildings. So we're just trying to incorporate. The minimum is that it has a -B or -A. This product uses the EcoPort certified SkyCentrics SkyBox, and it's therefore compliant. Then they get an open ADR listing under our listing, right? Because they have to use our cloud currently to be able to be open ADR. So that's what it says. The appliances below are only open ADR certified when connected to the SkyCentrics certified cloud. Okay, so who we work with, where are we, what are we doing? So Mitsubishi Electric, in this group, I think a lot of you have seen the Bayview apartments with the QAHV heat pump water heater. Small Planet Supply presented last week. They're working with the Sandon Eco 2 controller. And then Colmac is hoping to very soon be on board, and it'll retrofit any Colmac system. Obviously, it's available for others as well. And multifamily is really a sweet spot. So these are garden style apartments in Hawaii. And you can see there's 6 apartments per building. And we were able to do EcoPort water heaters for everyone and put a SkyBox gateway in every building. And that's exciting there. That is a picture of the Bayview apartments right there. So everybody's heard about that. And why is multifamily so important? Number one, it's bigger loads. It's one landlord or one developer or one owner typically. Obviously, condos where every apartment is separate is a little less exciting. You talk to one landlord, you get a big unit. The Bayview is about 18,000 watts. When you compare that, and that's a heat pump, right? If one heat pump water heater typically uses 400 to 800 watts, so 18,000 watts is a big difference. And that's the central system heat pump that's on Bayview. These are other apartments and apartment numbers that we're doing. So we really appreciate all the engineers we've worked with. The engineering companies are excited to have the data. That's again Bayview. You've all seen that. So what is the whole point of this, right? Now that we're freeing the machines, giving the machines a voice, letting them easily get up to the cloud, get weather data, what are we doing? We're optimizing, we're scheduling, and we're orchestrating. So how does the SkyBox optimize energy use? Well, the engineering companies we work with monitor and optimize performance to increase the COP and decrease the use of less efficient swing tanks. So in all those apartment buildings I showed you, that was the most important thing, the engineers working with the OEMs to help everybody reduce the COP and make them more efficient. Keep that 300 to 400% efficiency. And then the swing tanks are an electric resistance tank, sometimes even a gas tank, and you want to figure out ways to use that as least often as possible. So this access to the data, to the controls, either directly to the controls of the machine or just being able to send load up and shed signals. That's how we do that. Now, obviously, there's also time of use. So some of the apartment buildings we showed you are in California. They have a 4 to 9 p.m. time of use where it's more expensive. So after tweaking it and optimizing it to not use the swing tank very much, the next thing they do is they want to try and load it up and turn it off from 4 to 9 p.m. So what you're seeing here is some water heaters reporting the advanced load up. Now, this was interesting. These were water heaters that only reported the advanced load up when you sent them an event. But we've worked with the manufacturers to now get that orange curve, that orange part of the graph, to happen all the time, right? So there's a parallel line saying basically, hey, if you do an advanced load up, you'll get this much watt hours of energy take. I saw Bob Bass was on our call, and I think he came up with the word energy take. I used to talk about it as storage capacity, but I think energy take, how many watt hours will this water heater system take? How much energy will it take? So we're excited to have advanced load up and to be able to have these water heater systems giving us the advanced load up. That's for sure in residential. It's not always the case with the commercial systems, but that'll be the next phase. Then finally, we orchestrate. So optimizing and scheduling is for the building owner, right, to reduce their costs. And orchestrating is obviously what we're all looking for. How do we orchestrate loads to flex to grid and carbon peaks? So there's the Midas server in California delivering prices, time of use rates, even greenhouse gas emissions data. So if somebody wants to be really focused on the greenhouse gas emissions right now, the good news is it's typically very aligned with the prices. So if you want to be, you can be a good citizen for both. And it's critical to have good default behavior when connectivity goes down. And this is an important nuance. So now that we're trying to have more connected devices, there's a few things to think about. What happens if you have a million systems, a million water heaters, and they're now acting like a peaker plant? And every day they're providing value to the grid. And for some reason, 500,000 of them go offline because of an internet outage. Well, do they all instantly go back to their normal random behavior? And you saw those peaks of our water heater data, right? Their random behavior is coming on and peaking at exactly the wrong times. So if 500,000 lose connectivity, we don't want to have them be random behavior. We want to have them somehow either have a default schedule that they turn to that's at least a reasonably good citizen. You can imagine, hey, load up before 6 a.m., turn off from 6 to 8 a.m., load up until 4 p.m., turn off until 9 p.m. That's kind of standard. At the very least, that would be better than random behavior. And then maybe can the aggregators, the virtual top node OpenADR servers, can they preload weeks of events so that, you know, that August lake filling where I showed you how it was wiggling so much? Well, gee, it would be nice to, instead of just a default schedule that's essentially a time of use schedule, hey, can I kind of predict? Utilities are pretty good at predicting certainly a day ahead, sometimes a week ahead, and maybe I can preload events. So we certainly have that on our platform. You can preload months of scheduled events. And then we have a data buffer. So the data buffer says we can keep a year of data in that machine so that yes, when it was offline during the event, but because it was preloaded, it followed the event. And later, when it comes back online, you see that it followed the event. So we're very excited about that. We think that's super important to keep in mind. All the utilities on this call, when you are working with demand response, flexible, distributed energy resources, you want to make sure that you ask your aggregator and anyone, hey, what happens if the connectivity goes down? Does it go back to random behavior, or can we expect something a little better? And finally, this is a pitch to, hey, we tune our cars. Why don't we tune our buildings? So this is a building, 40,000 square foot commercial building in Oakland. You can see that it was tuned with a lot of Internet of Things, special things from an older company that was bought by GE. It was called Daintree Networks. And this, look at how well tuned this was. This is midnight to midnight on the x-axis. This is a month of data. You can see the weekends in blue where not much energy is being used. You can see that it's August, so it needs cooling in the afternoon. And then look at how every year it goes more and more out of tune. More energy being used on the weekends, more energy being used Sundays and Mondays. And then, you know, midnight, it starts, instead of starting at 6 in the morning, now it's starting at 3 in the morning, 2 in the morning. So let's tune our buildings. What do we need to be able to do that? We need analytics, we need data, we need connected loads, and we can reverse this negative behavior. And I just want to finish with a summary of what we covered. We want to connect to as many large loads as possible. SkyBox helps do that. We want to start using AI and ML to predict behavior and therefore have better ability to pick the right times to shed the load, load up the load while maintaining customer comfort. We like to say we optimize to cost, comfort, and carbon. And finally, optimize and schedule for the building owner, orchestrate for the grid. And that's my presentation.
Really excellent, Tristan. Thank you so much. Love the filling the lake analogy. I don't think I'd heard that one before, and it's really perfect for alleviating the duck curve. So yeah, if any folks have questions, feel free to come off mute and let Tristan know, or I also have some questions too. Chris?
Yeah, thank you, Tristan. That was a great presentation. So with the load shifting in there, you're shifting away from peak pricing to to lower costs. Presumably, once you get the deployment of a technology like that wide enough, you're going to start to impact the actual grid load and have a real impact on those peak times and take that off. Have you guys done any analysis to try to estimate what that impact would be on the sort of the wholesale price of electricity in those peaks? Because that's going to impact more than just the participants in your system. That's going to impact the market writ large and have
Yes.
ripple benefits.
Yeah, Chris. So that's a really awesome question. As you know, the grid peaks are really challenging for the grid. I'm pretty sure, certainly the National Lab folks that are on the call often know more about the details of this, but I'm pretty sure that if we could have a perfectly flat line of demand 24 hours a day, the grid would love that, right? They can just predict it, whether it's nuclear or coal. If it was flat, it would be so much easier. And a few ideas on that. Like we tried to understand how much the peaks really cost the grid. So the only paper we found that helped us take a look at that was a 2015 paper in Massachusetts called about battery technology, and it said things like 10%. 40% of the grid cost, the annual grid cost for Massachusetts was in 10% of the hours. Like if you looked at the 8,000 hours a year, 10% of those caused 40% of the grid cost. And you could imagine that those are the peaks. And if you could shift them and fill the lake, you could save 40% of the grid cost, the yearly grid cost. And I think it was, and by the way, the Massachusetts grid at the time was a fifth of the California grid. So certainly there's tons of value at taking the peak, shifting it to in a reliable way. I think the other tricky part is the utilities have said, gee, we push these demand response buttons and we don't get what we call firm dispatchable load. And I certainly know some of the aggregators in some of their presentations in the last year, they've really worked on trying to make demand response and flexible load kind of more predictable and more firm dispatchable. So the other thing you should know is there's two other things that CTA 2045 committee is working with, because we're starting to meet and kind of figure out what's the next release going to be. And two things we're working on. Number one, a feathering for the snapback, right? So you can imagine if everybody's turning off these 18,000 watt heat pump water heaters, at 9:01, they all come on. That's a huge snapback. If they're all loading up and they're all loading up 3 to 4 p.m. before the time you want them off, that's an artificial peak. So how can we feather it, right? How can we make it so they don't all come on at 9:01? We can certainly do that by grouping. Most aggregators can just divide it into 10 groups and feather them, but maybe we can have that be part of the system. And then the other thing is, I'm always amazed that after a week of being off, a grid can actually start, because you can imagine that after a week of being off, all the water heaters, the minute you turn on the grid, they're all going to turn on because they've been cold for a week. So, gee, a water heater especially, if it waits for 10 minutes after a cold start of the entire grid and comes on, feathers randomly, the million water heaters feather when they come on, that would be really helpful. And that's called the cold start problem. So Chris, did that kind of answer your questions?
Yes. And I'm going to go see if I can find that Massachusetts study.
It's on our website in the studies section, and
Excellent.
a little bit of our analysis. And the one other thing I wanted to say is that you asked a little more complicated question. Hey, how is that going to affect wholesale prices? So the study will help, but certainly, reach out to your national labs, to AWHI, NYSERDA, because hopefully they're studying some of this.
I work for NYSERDA, so that's yeah, I'm with you there. And the black start problem was an interesting wrinkle I'm taking a note on as well. So thank you.
Yeah, thanks for reminding me of the right word.
Yeah, Chris, I remember we chatted a while back trying to determine the impact utilities, right, for these peaks, and so difficult to find anything, really that clear about it.
Yeah, I suspect the data is out there. It's just either nobody's looked at it that way or nobody's published it. But
yeah. That
it's
Massachusetts paper was amazing for the granularity of the detail. It was pretty exciting.
cool. Well, thank you very much. I really appreciate it.
And then, yeah, so we had another question from Chris Mellon. Can this technology interface with PSPS events? Interfacing with the utility DRAS signal of a pending PSPS event would allow an intelligent control response.
So I'm not quite sure what a PSPS is, but obviously once you're connected by low-cost cellular, and we're constantly working with the cellular companies to say, hey, these things don't move. You're not going to have them all suddenly appear in a football stadium. They deliver very small text bandwidth. Hey, can you give us a good price? So low-cost cellular is exciting. It's here. And the question was, shoot.
Okay, no worries. Can this technology interface with PSPS
the PSPS events? What is a PSPS?
And so that is a public service power shutoff emergency.
Yeah. So look, we SkyCentrics have never connected to that signal, but absolutely, right? I mean, it's cloud to cloud at that point. So to connect to that signal and to say everything we're going to do is going to use less energy during that signal. And by the way, if you can give a warning signal so that you're going to say in an hour we're going to call that, then we can load them up and they can go even longer. Because I want to emphasize to everybody, all of these systems have smart responses ideally, where even if you tell them to shed, if they're nervous that they're going to have a cold water event, they come on briefly. So that's very exciting too.
Thank you, Tristan. Yeah, okay. So, and then I had another question too. So we know that especially for these central heat and water heater systems, demand charges from that additional load can really wipe out the cost gains that you would be getting normally from becoming so much more efficient. So does SkyBox have a way to try and mitigate the additional mitigate those demand charges or predict when they might happen, when the building is going to peak for that key 15-minute window in a month?
So that's actually what we've been working on, the next step, and it's really critical. I didn't present it here because we're just starting to do that. If you think about it, right, I told you about how first the engineers tweak it to not use the swing tank. Then they might tweak it to not come on 4 to 9 p.m.
Yep.
And even Bayview had picked some artificial times. Well, if you don't come on from 4 to 9 p.m., it's guaranteed that 18,000 watts is going to come on at 9:01.
Yep.
So literally today, I'm installing Rainforest Eagles. Hallelujah. A $99 box that can read a commercial meter. Not always, but we're working with PG&E on this. We really appreciate it. And it can read a commercial meter for $99 and deliver us 5-second real commercial meter data. If we don't have access to a Rainforest Eagle, and by the way, some smart meters are now allowing Rainforest to even put the code on the meters, so it doesn't even cost $99. But if you don't have that, you have to go to other solutions that are $1,000 to $5,000 of getting it installed by a professional electrician. It's, this is high voltage stuff. And God forbid you don't want to turn the building off. So we love the Eagle, and we're putting it in those Tenderloin buildings in San Francisco. And we're going to now look at, hey, if we're predicting the meter behavior, you saw that meter data, those beautiful heat maps, right, that I had.
And those are great.
So that comes from our algorithm to predict 24 hours ahead the meter data. So now we're looking at that, and we look at our prediction, and we say, gee, if we can keep that 18,000 watts off until 9:45, man, that's going to really reduce the peak demand charges. And then let's say we find out, no, we don't think we can keep it off till 9:45, but hey, if we start it at 7:45 and run it for 10 minutes, even though it's time of use higher price, we're not going to affect a peak, and we can slide it in there and get all the way to 9:46 and avoid that peak. So we're super excited about that, and we think that that's going to be really important, because we don't want people to be decarbonizing, shifting from gas boilers to these electric heat pumps, getting tons of efficiency, but having a whole new problem of much higher peak demand charges, which, as you know, can be 40 to 70% of a commercial building bill.
Yeah, thank you for emphasizing that statistic there too. I mean, these are really not insignificant, and it can be a barrier for folks to electrify, especially in multifamily buildings, right? They don't want to get hit with these extra demand charges. So yeah, thanks so much for that rainforest solution rundown. That's super exciting. And can I ask you made these graphics, Tristan? These are the heat maps?
Oh, that's on our platform. You have the minute we get meter data, we make those heat maps, and our customers, our building owners, can go and click and look at their heat maps.
Excellent. That's really a cool feature. Okay, we had another question. So Stephanie Wayland from for low-cost cellular connections, how do you minimize the amount of data transferred?
Yes. So number one, with our Wi-Fi solution, we heartbeat data every minute, but if there's a change, it's every 10 seconds. With cellular, on a residential water heater, we switch that to every 5 minutes. Now, look, at some point, we might say, only send us when there's a data change. Don't even do it every 5 minutes. And we use MQTT, so we know when a device is connected almost independently of much data being transferred at all. But it's important to keep the device connected. It's important for the utilities and everyone to know whether the device is connected. Certainly our building owner customers want to know when it's not connected and whether they need to go and fix the connectivity. The nice thing about low-cost cellular, much more bomb-proof. And as I said, even if it's off for an hour or two a day, sometimes cellular, those bubbles wave through the air and it gets disconnected. We do these preloads, we buffer the data, so that's super exciting. And so the question, can you just, Stephanie had said, low-cost cellular, how do you keep cellular down? So a couple other things. We're working with a number of cellular providers. It's a very interesting space, and we're constantly looking for ways to lower that cost. It's also exciting. I talked about the internal daughter card of the SkyBox, right? So we can swap out the daughter card for satellite, even with cellular backup. So we have a great partner for that. That partner also works globally. And we're working with some foreign countries that have found out about CTA 2045, and there could be announcements in the next 6 months about some countries getting excited to go full bore on EcoPort water heaters.
That's really incredible too. Yeah, because the more different examples and different types of grid setups, different types of utilities, that would be awesome. And then just moving the market forward, right?
Yeah, well, it'll really help because all of the module vendors obviously want to lower the module costs because that's historically been a little bit of a barrier. But no module vendor has ever sold, from what I know, 10,000 modules, for example. And you know how electronics work, right? If you can order 100,000, you're going to have your USB port for machines is going to be as cheap as a USB port for computers.
Absolutely. Yeah, great analogy there. Any other questions, folks? Alrighty. Well, yeah, thank you again, Tristan. That was really, really great. Love the overview. And yeah, just excited to, see this technology keep growing and all your new solutions coming on board. And we'll definitely have to chat again about the demand response, because certainly something that is coming up on NBI projects as well.
All right. Well, thank you, everybody.
All right, so I'm going to go ahead and share my screen again. We just have one discussion question, and then we'll wrap it up. All right, so one thing that was brought to my attention recently was that sometimes for commercial systems, commercial heat pumps, turning the compressor fully on and off can kind of affect the health of it and affect its longevity. So I was wondering if folks had any opinions on that. I know there are types of compressors that allow them to kind of turn down rather than turn on and off completely. Also wondering if this is an effect for single family homes. Doesn't seem to be as much, right? With like 120 or 240 volt single family home water heaters, the on and off seems to be less of a big deal. So wondering if anybody knows more, because this has been coming up a bit in recent conversations. Tristan?
Yeah, so hopefully one of the OEMs is on and can discuss this more, but that's the beautiful thing about a request signal instead of, for example, historically we have 8 million water heaters in the United States that have been turned on and off. It's electric resistance, not a compressor, but turned on and off by a radio signal, and all it does is cut the power. So definitely cutting power to compressors like right when they're turning on, I think that's bad. So it's wonderful that these OpenADR, CTA 2045 are sending requests. And the device says, hey, I got your request. I'm going to shut down safely. I'm going to turn on safely. So that's really important. And I think the other aspect to this, so I think that's kind of like guaranteed. Hey, we're sending a request and the machine is going to make a smart decision to do everything safely for the longevity of that machine. Now, there's no doubt that the other risk is, hey, if you ask the machine to go on and off, even if you do it safely, which means usually 15 minutes, but I just was recently talking to people who know a lot more than me about these things, and they said heat pumps love to be on for a long period of time. And, from our experience so far, certainly the Bayview project, the machine gets loaded up from 4 to 6 p.m. a.m., turned off from 6 to 8 a.m., run normal for a few hours, and then use solar to load up again for 4 hours for the evening peak, which is longer, and then turn off for 4 hours. So a manufacturer told me, look, when I have right-sized the commercial heat pump system, it should be on 16 hours a day. I've heard that from a few different ones.
Yes.
So that means you've got these beautiful 8 hours where, as historically, and I'll be getting baseline soon, but historically, it's not like they go on 16 and off 8. I'm sure they're going on and off a few times.
Absolutely.
And we're probably not changing that number very much with these sort of big load ups and sheds.
No, that's a great answer. I appreciate that. Because it has been raised, right? Especially for these really expensive systems, I think it makes sense to not want to void your warranty or have something negative like that happen. So we did have some more folks voicing in the chat. Jackson, we have seen early failure from residential units due to load shifts, even from OEM. Respond from voluntary requests. Interesting. But then Chris Mellon, you were saying, I have not seen any premature failures from scheduling water heaters. However, refrigerators do this all the time and last 20 plus years. So it sounds like, a little bit of a variation in knowing for sure here. But like Tristan was saying, right, they are requests. So potentially, when they're turning off in their cycle could make a big difference on that health. Again, I'm no expert here. That's why I wanted to bring up this discussing question just in case it comes up.
It's really the engineering side of the OEMs, right? That if they're going to make their devices conformant to 2045, then they would design those shut-off procedures as they would design any shut-off procedure that they already use, right? So you would never want to shut off a compressor because of how pressure gradient is going to affect the system. But I don't see it as a problem so long as these systems are engineered to shut off, and they should be already engineered to shut off because they do that quite often, right? So the request is what the message that's really important here. 2045 makes requests, and it's incumbent upon the OEM engineers to make their devices shut off in a way that's going to preserve that lifetime.
Thank you, Bob. Really appreciate that explanation. And then looks like Jackson chimed in one more time. OEM software to respond to RT signals are still in the early days. So there are some instances where special cases cause excessive cycling. Okay, cool. So these responses are making sense together. Thanks for your input, y'all. And yeah, so going forward, if there are any other discussion questions that are, burning for you that you've, had come up multiple times, maybe don't have a complete answer on and want to bring to this group, it's a great opportunity. As you've just seen, there's a lot of knowledge here. So really appreciate y'all. And then for wrap-ups, so the next meeting is going to be on October 11th, same time on Friday as always. We have Pierre Delforge from Harvest Thermal coming to present. So he's going to be talking about the integrated combi system that Harvest makes and how they're able to do load shifting. So definitely looking forward to that. However, that is just going to be a half slot. So if anybody else wants to, jump in for a 15 to 20-minute presentation on October 11th, please shoot me an email at noah@newbuildings.org, and we can definitely get you in. And yeah, so thanks everyone so much. Huge thanks to Tristan. That was a really great presentation. Really appreciated learning more about SkyBox. The recording will be sent out in the next week along with the slides. Cheers, y'all. Have a great weekend.
Thank you.
Thank you.